Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge, and the problem is bag of tokens. You have an initial power of power and initial score 0. Let us write income. Initial score is 0 and the tokens of I is the value of the ith token, 0 index. Your goal is to maximize your total score. We have to maximize our total score by potentially playing each token in one of the two ways. So if your current power is at least tokens of I, if my current power is at least my tokens of I greater than or equal to tokens of I, then what we can do is we have to lose the tokens of I power. We want to reduce my power to tokens of I times, and we can gain score also. So initially score is 0, we can gain the score, or else we can have to do another this another case, another way. This is case 1. So this is case 1, and what is our case 2? They are given case 2 is nothing but if our current score is at least 1. If my current score is at least 1, then what I have to do is you may play the ith token face down. Face down means we can gain tokens of I power, which is power plus equal to tokens of I, and we can lose the score. So we can lose the score minus minus. So each token may be played at most once in any order, so you do not have to play all the tokens. Return the largest possible score you can achieve after playing any number of tokens. So what I observe is these are the two cases that they have given. We can take some examples and see. So example 1, here they have given 100 as a token and power as 50. So since 50 is not greater than or equal to tokens of I, we cannot go on increment our score. And if my score is also not greater than or equal to 1, so this both the cases fails and we return 0. So next we can go and see example 2. Example 2, there is tokens 100 and 200 and power is 150. Since there is 150, then I can decrement my power with the tokens of I. But if we want to increment our score, we have to do this case 1. So we have to maximize our score. That is our ultimate goal. So if we have to maximize the score, what I observe here is observations. Let me write the observations. To maximize the score, we have to make use of this case 1. So we have to make use of this case 1, we have to deduct smallest value possible from our power. So to maximize the score, deduct smallest value from the power. So that is what I observe here. This is my first observation. So from this first observation itself, we can also define this case 2. If I cannot make use of this case 1, what I can do is I can make use of this case 2. If I make use of this case 2, what I can do is I am going to decrement my score with 1. I'm going to decrement my score to score by 1. So I have to gain tokens of I power. But to gain tokens of I power, what I can add is I cannot add very smallest value to my power. I should add a larger value. If I add larger value, then in the subsequent steps I can increment this score as well, or else in the meantime I will decrement the score and I will fail to reach the maximum possible answer. So what I observe here is to maximize the score and make use of the second case, gain the largest power. So since that we are making use of the smallest and the largest power, let us first try to sort the array. These are the observations. So let us try to sort the array, and we can have a 2 pointer I and j. So if my first case is existing. If my first case is getting true, that is power is greater than or equal to tokens of I. Yes, 150 is greater than or equal to 100. So what I can do is I can decrement the power with this tokens of I, which is 100. So now my power becomes 50. Now my power becomes 50. Now in my next iteration, this 50 is not greater than or equal to 200. So what I tend to do is, and our score is also 1. We have incremented our score is also 1. So we can make use of this second case. Score is greater than or equal to 1. So we can add the largest power to our power, which is 200 plus 50, 250, and score decrements by 0, and we will, for each and every iteration, we are going to update our score. So this is our logic, this is our logic here. So let us try to dry run for this example 3. Already the given array is sorted, so 100, 200, 300 and 400. What we are saying is we are having an I here and we are having a j here. This I is going to say the smallest possible value that I can deduct from power, and j is the index of the largest value that is going to gain power, such that we can decrement one score. So first, initially the score is 0 and my power is 200. So what happens is 200 is greater than or equal to 100. So what I will do is I will decrement my power with 100 and it becomes 100, and I will increment our score. So next my I moves to next pointer. And since now my 100 is not greater than or equal to 200, now I'm going to case 2 and checking whether my score is greater than or equal to 1. Yes, since the score is greater than or equal to 1, we are just decrementing our score and we are gaining the largest power, which is 400. 400 plus 100, which is nothing but 500. So my j becomes to this pointer now. Now my 500 is greater than or equal to 200. Since we have to increment our score, we have to maximize our score. So we tend to do the first case on the first go, or else we will tend to decrement our score. So now my 500 is greater than or equal to 200. I will increment our score and I will decrement 200 from this 500, which becomes 300. Now my I stands here and j also stands here. Now my 300 is again greater than or equal to 3 score. So I will tend to increment my score and my score power becomes 0, 0, and we got our maximum answer. So we are updating our score as well, score in each iteration. So this is our logic behind, and let us try to code this approach as well. Hope you understand the dry run which I gave with several examples. So what we can do is, first we have to sort the array. Sort tokens dot begin comma tokens dot end, int I equal to 0 and j equal to tokens dot size minus 1. While my I is less than or equal to j, I am going inside this loop, and what I'm doing is I should have a variable declared, which is int score is 0, and score is 0. My power, I have a variable already, and I also want to return a max score. So I will initially have it as 0. Return max score. So what I'm going to do is, at the end of the day, I'm returning this max score. In our loop, we are checking for the first case. First case is nothing but if my power is greater than or equal to tokens of I, then I tend to increment our score, after which I want to decrement my power with my tokens of I, and I want to move my I pointer. Else if my score is greater than or equal to 1, if my score is greater than or equal to 1, I tend to gain the largest power. So first I will decrement my score, after which I am going to gain that much power there. So power plus equal to tokens of j minus minus. If both the cases is not working for me, then I'm just breaking out of this loop, because I cannot do both the cases. I cannot do both the cases, so our pointers I and j pointers will be not moving at all. So we, for each and every iteration, I am going to store my max score as well, max score of my score. And let us try to run our code and see. Here the time complexity will be order of n log n, since we are sorting the array, and the space complexity will be order of 1 since we are not using any extra space here. So the example test cases are passing. Hope we can submit our code. So it got accepted. So that's the pretty much for today. Hope you like this solution. Let me know in the comments. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.